Alright, then welcome back everyone. Let's solve this question, move brackets. Now this is a simple question based on greedy. I think most of you would have already solved this, but yeah, let me just quickly summarize the question for you. We are given a bracket sequence s of length n, so there's just a string of length n given to you, and this n is even. What the string contains is, the string contains only opening brackets and closing brackets. More specifically, n by 2 opening brackets are there and n by 2 closing brackets are there. And there is this move defined here. What is a move is, in one operation you can move a bracket from any index to either start or end, right? So exactly one bracket, choose exactly one bracket on any index and move it to the beginning of a string or end of a string, right? So that's a move defined here. A task is to find the minimum number of moves required to obtain a regular bracket sequence. Now what is a regular bracket sequence? So this string right now of just n by 2 opening brackets and n by 2 closing bracket, it's a sequence, right? And what you want to achieve is, by using this operation, that is, pick any bracket or from any index and move to starting or end of the string or sequence, whatever, you want to make it a regular bracket sequence. Now what is a regular bracket sequence? Regular bracket sequence, they have defined it. It's either opening bracket followed by closing bracket, or if you have a, let's say this is a regular bracket sequence, you can wrap a regular bracket sequence inside a opening and closing bracket, or if you have two regular bracket sequences, you can put them together, right? So this is a definition of a regular bracket sequence. In simple words, what is a regular bracket sequence is, whenever you are having a closing bracket, there should be a matching opening bracket for it, right? So if you have a closing bracket in your sequence, there should be a matching opening bracket for it, right? So if you have a closing bracket like this and you don't have a matching opening bracket for it before it, then there is a problem, right? So this is a string here. It contains like 4 characters, right? So even, and 2 opening brackets, 2 closing bracket. But see here, this closing bracket doesn't have any opening bracket before it, right? But this guy has it, so that's why. So whenever you have a closing bracket, there should be a matching opening bracket before it, otherwise it won't be a regular bracket sequence. So input is pretty simple. Like, what you are given is, you are given a n and s. N is length of string, which is 2p, and you have p open brackets and p close brackets, and for output you have to output the minimum number of moves required to obtain a regular bracket sequence. What is a regular bracket sequence? Like this, we already defined it. Fine. So what is the question then? The question can be summarized like this. We are given a string here, right, which contains p number of even opening brackets and p number of closing brackets, and we have an operation or a move defined, that is a move bracket from any index to either start or end, and our aim is to minimize this operation. Okay, so we want to minimize the operation. What is the first thing that comes to your mind? One thing that should come straight away to your mind is, if you want the operation to be minimized, that is moves to be minimized, don't choose the already matched brackets. In other words, don't meddle with already matched pairs, right? If the brackets, like if a pair is already matched, don't meddle with it, don't move it here and there, right? In the end, like, one thing is very obvious here, that you can always make a, like, given this sequence, you can make a bracket sequence regular always, right? Because what you can do is, in n operations you can move all of them to the left side, right? In n operations you can move all of them to the left side, and another n operation you can move all of them to the right side. So a sequence can always be made a regular bracket sequence, so that's not an issue. But if you want to minimize it, what you should do is, don't meddle with already matched pairs. So what I'm trying to say here is, let's just take an example, okay? So this is an example here. What I'm trying to say here is, these two are already matched, so don't meddle with them. Like, you can just pretend that they don't exist, okay? Don't touch these brackets, they are already matched. For example, these two are already matched, don't touch them. Don't do, like, assume that they don't even exist, right? Because this, like, you can say, in other words, this subsegment is already regular, right? This subsequence is already a regular sequence. In other words, this subsequence is already a regular sequence, like a regular bracket sequence. So don't mess with the subsequence which is already regular, right? In other words, don't mess with this, right? So assume that this is not existing, right? And now what you are left with is, two unmatched closing brackets and two unmatched opening brackets. All in all, if you don't touch the subsegments or the pairs which are already matched, you will be left with like unmatched opening brackets and unmatched closing brackets. In other words, since you're left with all in all 4 brackets, you are left with two unmatched pairs, right? You are left with two unmatched pairs. If you want to make this expression now regular, the sequence regular, you have two options. Either move this uh, opening brackets one by one to the start, right? You can do it, right? You can move a bracket from any index to the start. So in two operations, move this opening bracket to the start, or the option you have is move this closing brackets one by one to the end. You can do it. You can move any bracket to the last index. So in other words, what I'm trying to say here is, guys, after you have removed the sub segments like subsequences which are already regular, what you will be left with is something like this. You'll be left with like a bunch of closing brackets first, followed by a bunch of opening brackets afterwards. In more concretely, there will be like, if there are k unmatched pairs, there will be exactly like here k closing brackets first, followed by k opening brackets, and there will be some you can say subsegments, regular subsegments in between, right? So what are these regular subsegments between? There can be something like this, right? So there can be something like this which is matched, right? So after you removed the subsequences which are already regular, you will be left with a bunch of closing brackets followed by same number of opening brackets, right? So there will be, let's say here, k number of opening brackets followed by k number of closing brackets, and the minimum number of operations that you will consume is either move all of these guys to the end in just k operations, or move all of this to the start using just k operation. So yeah, I mean, that's your strategy. Let's try to concretize a little bit. So how are you going to achieve it? That is pretty simple. What you can do is you can probably maintain a stack here. Okay, you can maintain a stack here. What I'll do is I'll just push my opening brackets into the stack, and whenever a closing bracket arrives, so I'm just gonna push my opening brackets in the stack, and whenever a closing bracket arrives, I'm gonna match it with the closest one to it, right? I'm gonna match it with the closest one to it. Okay, so when this guy arrives, I'm gonna match it with this, so I'm gonna remove it from the stack. When this guy arrives, I'm gonna match it with this, so I'm gonna remove this from the stack, right? So like closing brackets, like here you will see that you don't have a matching opening bracket. So what you will do, like, you'll do nothing here, right? You'll do nothing here. What you can do is, again, so these two opening brackets will come now, so I'll add them to the stack. Now this will come, so this will be matched with this, so this will be removed, and then one more opening bracket will be added. So in the end, what will be left up with is the unmatched opening brackets, right? Because when these two closing brackets came, you had nothing in the stack to match with it. So in the stack, in the end, you'll be left with the unmatched opening brackets, and you can return the stack size. There are other ways to it. You can get away by not using a stack as well here, but the stack approach seems more feasible. That's why I'm using it. So let's just do a dry run one more time to get a sense of what just happened here. Let me go a little bit slow this time. But I guess the approach is clear, right? What you're gonna do is you're gonna come here, opening brackets into the stack, closing bracket will try to match. Okay, so that is a strategy. So opening bracket, right, add it into the stack. Opening bracket, right, add it into the stack. Fine. Closing bracket, match it. So this pair is formed. So remove it. Closing bracket, match it with the nearest opening bracket. Done. Closing bracket came. There is no matching opening bracket. Fine. Anyway, if there is no matching, they are not going to match it. So these two are left unmatched. If these two are left unmatched, its corresponding opening brackets will be left behind after the end of our operation. So you'll see what I'm trying to say. So then we'll come here, opening bracket added. I'll come here, opening bracket added. Come here. This closing bracket will be matched with a closing bracket. Like this closing bracket will match with the opening bracket. Fine, done. Come here, so opening bracket added, and we have reached the end of the string. Now we have reached end of the string, and the stack size is 2, right? So these things are removed. The stack size is 2. What does the stack contain? It contains the two unmatched like brackets, right? So in other words, these two open brackets signify there are two pairs which were unmatched, and you can make this bracket sequence regular by just performing two number of operations. What two number of operation? Either move these two at the start or move these two at the end, right? So yeah, I guess that's that about this question. Let's just quickly implement it then.
Okay guys, so let's just implement the solution now. I've already taken the input here. Now what I need to do is I need to create a stack, and the stack I'm gonna push the opening brackets, right? So I'm gonna go through all the characters of my string, and if this character is an opening bracket, what I'm gonna do, I'm gonna push it at the back of the stack, right? And else that is we have a closing bracket, we'll try to match it, right? We'll try to match it. That is, if st dot size is greater than 0, that it does not become empty, or you can write here not st dot empty, right? Then I'm gonna match it, right? So there is a match. So there is a corresponding opening bracket available for this closing bracket, right? So you can match it, and after the end of the loop, what you'll have is you'll be left with what? Those opening brackets for which the closing brackets are before it, right? So if you will be left with the unmatched opening brackets in the stack, so you can just return the size of the stack followed by a new line, right? So yeah, that's that. Let me just quickly run it. It seems to be working. Let me just now submit it then. Yeah, it works. Thank you for watching. I'll see you in the next one.